again, and welcome back to Chapter 11, Part 2. Yay! So we're going to continue talking about the central nervous system, and then we're going to dovetail into the peripheral nervous system a little bit. Now, this kind of is a big section, but I had to split it up this way. Also, this is where I get into all the wacky stories of brain insanity. So, with that said, let's go ahead and continue our travels into the brain and our spinal cord. So anyway, there we go. Remember, your wrinkles are actually really important. They actually have names too. We'll get to that in a moment. Monty, on the other hand, his brain doesn't have all that many wrinkles going on, so yeah, fun stuff. All right, so now that we've spoken about what covers the brain, let's talk about the brain itself. So, the brain is responsible for sensations and perceptions. It issues motor commands to the skeletal muscles and carries on higher mental functions such as memory and reasoning. And some reasoning is better than other reasoning. The brain also contains neural centers and pathways that coordinate muscular movements and others that regulate visceral activities, so we don't have to think about them. The brain is responsible for characteristics such as personality, which will bring us to the story of Phineas Gage. So, now, before we get into all the weird stories, how does the brain develop? And the brain develops in a very interesting way in a fetus as it's growing into a baby. It's really interesting. I liken it to making balloon animals, because that's kind of how it is. It kind of starts out kind of like a straight tube, and then it starts folding back on itself and forward and back and forward, and it's really interesting. So it's kind of like balloon animals to me. So first it starts with this neural tube that develops three parts. You got your forebrain, the midbrain, and that's going to get folded back and shoved up into the brain, and the hindbrain, and then the spinal cord. So the hindbrain is also known as the rhombencephalon, because that's just fun to say. So the forebrain is also known as the prosencephalon, and the midbrain is called the mesencephalon. Isn't that fun? I don't know why. They're just kind of fun to say. Anyway, so then later, the forebrain divides into the anterior and posterior portions called the telencephalon and the diencephalon. And they come back later. As well as the hindbrain that partially divides into the metencephalon and the myencephalon. So, you got all those cephalons straight? Yeah. So anyway, as you can see, so we got these three parts here at 5 weeks, and then the forebrain is swelling up into the cerebellum, and that thing gets really big. And the midbrain actually, so what happens is this gets bigger, and the midbrain actually folds up into the cerebellum, or the midbrain swells up into the cerebrum. The cerebellum then gets bigger as well and sits at the bottom of the cerebrum, and then you got the medulla that folds forward and then continues down into the spinal cord, which, like I said, I kind of liken it to balloon animals. So, as you can see here, we've got basically all the different parts at 5 weeks. We've got the telencephalon, we've got the diencephalon, and the mesencephalon, and like I said, these guys are going to fold back, where this basically gets bigger, and kind of sits and covers this whole section right here. The pons and the medulla start showing up. And again, these guys get big, sits back on these guys, sits back on the cerebellum right here. The pons shoots forwards, and the medulla and the spinal cord. And then this is where you see your midbrain disappeared into. And again, becomes a diencephalon, and here comes, the midbrain, the pons right here, and the cerebellum, and the medulla oblongata. All of these are very important. Like I said, these guys are kind of like the older versions of brains. Like, these are the ones we kind of share with other animals. Uh, the big cerebral hemisphere we share with a lot of the mammals. So, you know, if you look at a lot of different creatures, they have a similar layout for the brain, especially in the mammals. But Monty, like right here, he's basically sitting on like these older parts right here. He literally, the size of his brain is a pea. So, you know. Yep. So literally, snakes are pea brains. Anyway, so regions of the brain, this is where we get into the cool and weird stories. So right here we've got our frontal lobe, and remember we've got the left and the right hemisphere, which is the cerebrum right here. We got the temporal lobe right here, the parietal lobe, the occipital lobe, which basically figures out what we see, which is weird because the eyeballs are right here, and then we shoot it back to the back of the head and sit there and figure out what we're seeing. Why? I'm not entirely sure. Please ask somebody who's got way more experience on that end. Cerebellum's hanging out, and then you got your brainstem with your pons and your medulla oblongata that then goes down into your spinal cord. So basically, you got your cerebral hemispheres, your cerebrum, your diencephalon, your brainstem, and your cerebellum. Those are your four major parts. And like I said, you break them up into different things. So let's go from the neck up. So you got your brainstem. This is basically where your brain connects to your spinal cord. You got your medulla oblongata. That's this enlarged spot right here. So the spinal cord is coming up. And the first bump you see is your medulla oblongata right there. And this controls your heart rate, your smooth muscle control for your blood pressure and vasodilation. So if you blush, that's basically what's going on there. And the basic rhythm of breathing. So you don't have to think about it too hard because you've got your medulla oblongata to do it for you. Again, this is an older section of the brain. This is stuff that you'll see in lower creatures too, over and over again, like Monty here. I'm not saying you're a lower creature. I'm just saying your brain's a whole lot simpler than ours, man. Anyway, you got your pons, which is this rounded bulge right here between the midbrain and the medulla oblongata. And this relays information between the medulla oblongata and the cerebellum. So basically, sensory information to control breathing with the medulla oblongata. So this is one where it basically lets you know that, okay, we can take a breath and yeah. This is the one that translates that, and so when we need to do that. So the mesencephalon or midbrain, this is the main pathway between the cerebellum and the lower parts of your nervous system. It also contains sensors for visual reflexes and auditory reflexes. So when my son goes, ah, and I'm like right next to him and I go, that's basically the midbrain going, ow. As well as red nuclei that communicates with the cerebellum and centers of the spinal cord and plays a role in maintaining posture. So if you're one of those that likes to slump all the time, and sometimes I do that, and sometimes I remember I need to sit up and drop my shoulders and not build up my stress in my neck. Yeah, that's where basically what we're doing there. Now, cerebellum. So this communicates with the other parts of the CNS by tracts. It's this cool thing sticking out the back, and if you've ever watched it's actually kind of funny if you ever watch Powerpuff Girls, the original. This is Miss Bellum. Her name is Sarah Bellum, get it? And her hair was always in the shape of a cerebellum. Anyway, so this integrates sensory information concerning the position of the body parts, coordinates muscle activities, again, helps maintain posture. Like I said, all of these guys are extremely important in maintaining a lot of the autonomic things that we don't really think about not terribly much. And we don't have to, thanks to these guys doing it for us. And Monty, who's leaving. Where are you going? There's nowhere to go. Anyway, the diencephalon. So this is largely composed of gray matter. It's located between the cerebral hemispheres and superior to the brain and surrounds the third ventricle. This is basically where our control unit for our next major system that we're going to talk about in the next course, starting off in 169, which is your endocrine system. So this is where your thalamus is, your hypothalamus, who's huge. Actually, he's really tiny, but he's huge in what he does. And the epithalamus, which connects the limbic system to other parts of your brain. Limbic system being the one that is responsible for analyzing smell and memory and emotions, which is kind of interesting, which is why smell is very much related to memory and emotions. So these guys right here, we get to talk about them constantly in the next semester. So if you're taking 169, these three, especially our boy hypothalamus, shows up big time. So that's where we talk about these guys. Because these guys control all the hormone fun going on in your body, which works in conjunction with your nervous system on maintaining things that your nervous system can't, is too direct. There's some things in your body that the nervous system is really good for direct messaging, which is great, but we also need something to do a little slower messaging, and that's where our hormones come in for long-term stuff. Anyway, then your cerebrum, which is basically the largest part of the mature brain, is split into two cerebral hemispheres, which are essentially mirror images of each other. And it's really interesting because the left side of your brain actually controls the right half of your body, and the right side of your brain controls the left hand of your body. Yeah, you're backwards. Because it's weird like that. So anyway, we've got integrative centers that receives information from somatosensory, visual, audio association areas, which we're going to talk about in the last chapter, chapter 12. Primary gustatory, olfactory, thalamus, and other parts of the brain. And it integrates all this information to allow formation of thoughts and a variety of sensory inputs. Then we've got motor areas. These are responsible for movements in our skeletal muscles. So, we don't move like robots. And cells in the upper portion of the motor areas and sending impulse to the thighs and the legs. So get this. So the upper portion of your motor area controls the bottom portion of your body. The middle portion controls your arms and your forearms, and the lowest portion of this controls your head. Backwards. Again, when I was saying in earlier chapters how beautiful some of these things are, and it's amazing, and it's gorgeous, and it's elegant. Yeah, and then you get to some parts of your brain, and you're like, what were we thinking? Anyway. So yeah, the top part of the motor area controls the bottom half of you. The middle part controls the middle half of you. And the top part, and the bottom part controls the top part of you. Like I said, brain is weird. Anyway, association areas. These analyze and interpret sensory experiences and help provide memory, reasoning, verbalizing, judgment, and emotions, like our front sections. The actual last part of your brain to develop in your life is actually your frontal lobes. And it actually doesn't finish developing until your mid-20s. So, which is why teenagers have such bad impulse control. And I'm not knocking teenagers. Like I said, I worked with them for 16 and a half years. I prefer teaching teenagers and adults because little kids freak me out. I'm sorry, I don't know how kindergarten teachers do it, and I really, really, really don't know how middle school teachers do it, because middle schoolers are crazy. They need pay grade over everybody else. But anyway, what's happening in the high school and definitely in the middle school dimension is the fact that there's no impulse control, because their frontal lobes are still developing, and that frontal lobe is extremely important. And that's why you get poor judgment calls. When you ask a kid, especially in middle school, why did you do that? They can't tell you. They never will tell you because they don't know themselves. So don't ask them that question. I know it's hard because we'd like some justification for the insanity, but there is none. There's just none. That's why teaching middle school just escapes my patience tolerance. I can teach high school fine. Middle school? No, they're crazy. I can't do it. I don't know how middle school teachers do it. They're special. They're special. They deserve crowns or something. Anyway. So yeah, frontal lobe, which brings me to how did we figure out personality hangs out in the frontal lobe? Well, that comes back to around 1900s. And a guy by the name of Phineas Gage. Did I put him in here? Yeah, okay. We'll talk about Phineas in a minute because we got the lobes right here. We'll talk about the lobes in a minute. So anyway, we got the gyri and sucli. So the gyri are the ridges and the convolutions that mark the cerebrum surface. So the shallow to deep grooves are called the sucli. And this increases the amount of surface area of the brain that can fit into the skull. Because compared to all the other mammals, we have huge fat brains, including the other primates. We have huge fat brains, which is why we have to take so much care of our babies, because they come out with huge fat heads because of our huge fat brains. So it's not like whales that have a huge fat body to match their huge fat brains, because they're darn smart too. Just look at all the orcas right now having a field day, knocking out all the yachts. They're not stupid, guys. They are not stupid. Anyway. So anyway, but because we have big fat heads, we still need a lot more, room. So we've got, remember what I said, anytime you see folds and everything like that in the body, that means we need increased surface area. And that increased surface area means we can think. So, however, and there's this thing on the internet calling, oh, I'm smooth brain, I'm dumb. Well, there's actually something to that. Not having gyri and sucli is not a good thing. This brings me into what the Zika virus. So if you remember about, God, it was but way before COVID, not too way before, maybe a couple of years before COVID. So what, 2018, 2017, there was a scare of a new virus called the Zika virus going through. And it was definitely hitting South America and Central America because it was it's coming in on mosquitoes. And unfortunately, it was just another mild virus that acted like a flu and then got out of her system. So it wasn't really anything that was looked at too terribly. We noted it and moved on unless it hit a pregnant woman. If it hit a pregnant woman, the virus would attack the baby's brain. And unfortunately, the brain didn't develop and it was completely smooth. And literally smooth brain, really bad. Because again, increased surface area means increased active neurons, which means increased brain activity, means, we're a functioning human being, give or take. So yeah, unfortunately there was a slew of babies born thanks to the Zika virus with literally smooth brains. Not a gyri or sucli to be seen, which was really bad. Unfortunately, they are... This is where, the dark side of science comes in a way, in the fact that it's like, I hate talking about people like this, but unfortunately they are literally going to have to depend on others for the rest of their lives because they cannot learn, they cannot take care of themselves. They will essentially just be babies for the rest of their lives. Unable to learn or take care of themselves or anything because their brains are just not capable of anything a normal brain can do, aside from, the regulation of autonomic responses like, breathing, eating, stuff like that. Stuff that we don't have to learn. So these children, when they grow up, are pretty much just going to be humanoid vegetables. And I hate saying that. It bothers me as a mother and as a science person to actually sit there and say something like that, but that's basically what these children are going to grow up into. They said the worst thing about it is after they were born, their cries were so different, and it was just heartbreaking to all these mothers that knew they had been infected with Zika. And down in a lot of the South American countries, they couldn't abort because it's illegal down there, and now they're burdened with these, it's rough. I'm not doing the pro versus no. I'm just pro versus choice here. I'm just saying that's a rough spot. They didn't sign up for that. And, it's just, because like I said, they're not going to be anything for their lives. So anyway, so yeah, brains need wiggles. And now to talk about the reverse of that. So once upon a time, Einstein died. Hopefully you know who Albert Einstein is. Yes, and it's Einstein finally passed away. I forget at what age. I should look that up. Anyway, but crazy story. His family, didn't really want an autopsy or anything like that. He did die of, natural causes, kind of, sort of. He was old. So, and he was, being prepared to be, cremated because he came from a Jewish family, and, they observe certain rituals, just like, any other religion does. And so the family basically, and Einstein said, yeah, nobody gets to stare at my brain after I'm dead. I don't care what you people think of me. Leave my brain in my body. Well, the only person that didn't get the frickin' memo about that was his The mortuary guy, so the Undertaker, and I don't mean the wrestler, I mean, the actual the guy that got the body to prepare his body to be ready to be cremated and whatnot, decided, God, it would be such a loss if we lost Einstein's brain, even though that's what Einstein and his family wished. So the guy took it upon himself to take Einstein's brain out of his body, then put his skull back on, make it look like nothing had happened, and ship the body off to be cremated and buried as per Einstein's and family's wishes. And he kept the brain in a jar. And he fancied himself a scientist. And FYI, a lot of mortuary people aren't actual scientists. You can actually get a mortuary certificate pretty easily. There's a lot of people who are even unlicensed. So you can run, a home, or not a home. You can run your own mortuary place. Can't think now. Without really doing terribly much. It's kind of unregulated, which is actually where half the problem of the story came from. So, yeah. So he kept the brain, and he sliced it up into slices so he could look at it, but he wasn't much of a scientist, so he was just looking at the brain, kind of like you or me would look at the brain and go like, oh, cool, a brain. And that's about it. But he couldn't keep his stupid trap shut, so he bragged to friends, I've got Einstein's brain. And his friends went, wait, what? And he goes, I've got Einstein's brain. You want to see Einstein's brain? And he was like, oh. And he let people see Einstein's brain. He even sent some pieces of Einstein's brain to other people to stare at Einstein's brain. And finally he got caught, and Einstein's brain got confiscated. And now I believe it's in the Smithsonian, or at least parts of it are in the Smithsonian now, because the family is like, well, the brain's out of the head. I guess, nope. Oh well, thanks for breaking everything. And yeah, the guy, the Undertaker, got into buku amounts of trouble. But long story short, that's how we have Einstein's brain, because the Undertaker decided to take it. So anyway, so there you go. And come to find out, is Einstein's brain different from a regular human's? This is going back to the gyri sucli, where Zika unfortunately made many children smooth-brained. His has increased gyri and sucli. So Einstein's brain was actually foldier, if that makes sense. He had way more gyri and sucli than a normal person, which means he actually had increased brain mass. Not so much mass, but he had a lot of increased, he had a lot more folds. So was that because he was so smart? I don't know. This guy, well, keep in mind, Einstein also wasn't that great of a husband either, but, maybe he was dealing with some autism. Who knows? It's hard to go back in time and diagnose people. So, there you go. So, we went from smooth brain to super wrinkly brain, which is Einstein. Fun facts. All right, next up, let's talk about the lobes and what happens if you damage the lobes, which is not good. So again, the frontal lobe, I was just talking about these. So this is where we carry on higher intellectual processes for concentrating, planning, complex problem solving, judging consequences of behavior. This is the last to form in your brain, which unfortunately is why teenagers are a hot mess. So motor areas control movements, voluntary and skeletal muscles. And so, this is also why they're kind of uncoordinated, some of them. So anyway, so this is why concentration isn't so easy with younger kids, because the frontal lobe hasn't even remotely started. Like in my 9-year-old, it's like, they want them to do tests. And I get it, there's some testing you need to do so I can figure out where everybody is, how everybody's taking in the information as a teacher. It gives me a standing point to say, oh, not a lot of people got this, so I might want to go back and re-talk about that. There's times when it's like, I need that information from an exam or a quiz. It's not just for a grade. There is some logic and planning to these things. So I can look at these things and go, where can I do better as a teacher? But unfortunately, it's also been hijacked because certain people in power, like the numbers it generates, so that way they can say, my state's smarter than your state. And it's like, thanks. Anyway, but, they make, kids do these tests, and there's some tests that it's like, dude, they can't do that. Wesley, he's 9. But anyway, I'll get off on that. I'll get off into a whole thing. So let's get into Phineas Gage. So 1800, 1900s. And the reason we figured out the parietal lobe has a lot of our, a lot of our personalities inside as well as it develops, is because of this. So there was a guy named Phineas Gage. He worked for the railroad. I forget which one. There was a bunch back then, because the railroad was basically the main arteries of United States at the time. And we should really go back to it, but whatever. What do I know? I like trains. Anyway, so he was a foreman, and everybody who worked under him and also worked above him all agreed he was a great guy. He was a great guy. Give you a shirt off his back, sweet. He was fair. He was a good taskmaster for his crew. If something happened, he'd be fair with them, and he was a great guy. Everybody got along with him. Everybody liked him. He's a guy that you'd go out for a beer with, and you'd sit around and shoot the breeze, and everything would be shiny and awesome. Until one day, what happened is he was carrying around a pike, and I'll show you a picture of this, because holy crow. Not Phineas and Ferb. There we go. Phineas Gage. So you can see. Check this out. So, yeah, this is actual replication because we do have his skull, and we do have a ton of pictures. So he had this pike, and this is him holding the pike right here. It's got, as you can see, unfortunately, a point on one end and a little hook on the bottom. And what they do is when you're putting down the iron tracks, or not iron, whatever they were, the metal tracks. I like trains, but I don't know all the science of the trains. So anyway, so what happened is he'd tap it to see if it was in place. And if it was off a little bit, he'd use this little hook at the bottom and like hook it and move it over. Stuff like that. So anyway, so he was tamping around to make sure everything was solid and set. And just double checking his crew's work when they're putting down the tracks. And unfortunately, for whatever reason, we're still confused to this day. And now I've got the hiccups. Whatever the heck happened. Somehow maybe a pocket of gas, whatever, I'm not entirely sure, but he was tamping it with the pointy end up, and he was fixing something, and it was pointed at his head, and something exploded between the bottom of his tamper, the pike here, and it went straight through his skull. Boosh! And you can see pictures of it right here. This was well documented. This is, of course, again, like insanely well documented what happened to this poor guy. And as you can see here, we've recreated it through literal, all the documentation from back then. And then we put it into a computer. And you can see how it literally just obliterated one of his frontal lobes. It also destroyed one of his eyes. But the crazy part is, this is the insane part. He lived. He survived. Which is like, because everybody that saw him thought he would die. They were like, oh God, poor Phineas. Oh no. And they were all freaked out. And doctors worked and tirelessly and saved his life. However, like I said, his eye was obliterated and a good chunk of his frontal lobe was gone. So there you go. And he lived. However, he was not the same man as he was before. And no, unfortunately not. Poor Phineas Gage was forever changed because it had whacked out a good chunk of his frontal lobe, and his personality took a complete 180. Instead of being the nice, fair-handed foreman of the railroad who was a great guy all around and everybody liked him and they saw him going places, he turned into a degenerate alcoholic. Well, of course, when you have a pike go through your head, I think anybody would turn to alcohol back then. They didn't exactly have decent painkillers aside from doping yourself up on morphine 24/7 or putting cocaine in your Coca-Cola. which is actually where the term Coca-Cola came from, because they literally put Coke in it. Anyway, moving on. Another story for another time. But yeah, his personality drastically changed. So that's when science basically started learning, oh, frontal lobe is kind of where some of our personality is. So yeah, he died like a couple of years after, and it was because he had turned into such a raging jerk. Nobody could put up with him. He was an absolute degenerate. He was rude. He was just bad. So he lost all of his friends except for one doctor that kept chasing him around and going, well, A, I'm going to study you, and B, this is fascinating but also sad that this guy that, had such a, everybody was agreeing he was going places. He was probably going to go up the echelon in the railroads and, make a name for himself and probably settle down and have a nice family. He was a real good guy all around. Everybody said so. So it just, and he died, and the only job he could get after this was working in a horse stable, and even then he finally got turned out because he was too busy cursing at everyone. Because, just look at how much it took out. Wow, that's insane. So, yeah, his goodbye, right lobe. So anyway, that's the tale of Phineas Gage. Now, what came of this other than we figured out, whoa, okay, so that just destroyed his frontal lobe. And how is that going to, work? Sorry, I was trying to go to here so you can see it just went completely annihilated his frontal lobe there. So anyway, yeah. But this also gave a doctor ideas somewhere else. So a few years down the line, unfortunately, this is where we also kind of got the idea of frontal lobotomies, which is not a cool thing at all. So basically one doctor who was, psychology, not necessarily medical, and he was questionable to begin with, sat there, was reading about this in the journals, and sat there and said, you know what? I bet you anything. We could take all these dangerous people that are in, the psych hospitals and cut their frontal lobe out, and they'll turn into docile people. Except because, look at Phineas Gage. He was a great guy, and then he did a 180. What if we can do that and flip him back from being violent and crazy to normal? So, unfortunately, and I do mean this unfortunately, he came up with the frontal lobotomy. And unfortunately, it became a craze kind of in the 1950s. That and zapping the snot out of people with electricity, which is kind of, electrotherapy is for the brain is kind of, I kind of file that under pseudoscience currently myself. But anyway, but yeah, it was kind of the rage, which is why, unfortunately, Rosemary Kennedy, who is kind of the wild child of the Kennedy family, and they feared that she was going to get even more rebellious, decided to just give her a freaking frontal lobotomy to make her more docile, more in line with the Kennedy brand. Yeah, it destroyed her. It turned her into pretty much, she's kind of the reason for the Special Olympics, because one of her sisters just looked at that, was horrified, and made the Special Olympics kind of in her honor. So, yeah. So, they did that to Rosemary Kennedy. They gave her a frontal lobotomy so that way she'd fit in line with the family. No, it didn't do anything. And then they said she was upstate healing. So they hid her afterwards because they knew they had screwed up and destroyed her life, which was sad. And then the fad was so bad that they actually did this to a 14-year-old, I believe, was the youngest person who ever got a frontal lobotomy for no reason. I'm not kidding you. So youngest, frontal lobotomy. So this thing, Howard Dooley. So he was 12. He was 12, guys, 12. He was 12. And his his stepmother said he was defiant and daydreamed and objected to going to bed. Guys, that's like, dude, like, I don't even like going to bed sometimes. It's like, dude, I want to stay up and keep reading my book. And I'm 43. So they literally drug him, and he got a frontal lobotomy. And you can read about it. He even has an NPR thing right here. Look him up, and you can hear in his own words what happened to him and how he feels like he's missing a part of himself to this day. He's still alive. He's 74 years old. He lives in California. And he is the youngest person that was ever given a frontal lobotomy because he was being bad. Just disgusting. And yeah, he's, but he still feels like he's missing a part of himself, and it's not cool. So like I said, I just because he was defiant and didn't want to go to bed and daydreamed. Oh no, God, I'd hate to see what that stepmother would say checking out some of my former high schoolers that I used to teach. God. Anyway, so there you go. Frontal lobe. Don't hurt your frontal lobe. All right, next up. Don't worry, I've got more weird stories coming for you. Fun. All right, temporal lobe. Yeah, the next story is not as depressing, I assure you. Temporal lobe. Association areas interpret sensory experiences and remember visual scenes. Music, other complex sensory patterns, sensory are responsible for hearing. Parietal lobe. I need to back up. Sorry about that. I don't know why I jumped to the temporal lobe. Parietal lobe, basically, this is an understanding speech and using words to express thoughts and feelings. This is actually when it's forming when your kid is young, especially in the kindergarten and pre-K age, because that's when we're sitting there going, okay, you've got to say your feelings. You've got to talk your feelings, because we're always talking about little kids too. Okay, what are you feeling? And instead of, like when little kids throw a fit and they try to, hit each other when they grab, one of them grabs a toy from somebody else, and instead of telling them to hit, it's like, no, use your words, because that's the parietal lobe developing then. So this in sensations of texture, touch, pressure, pain involving skin, like I said, understanding speech and using words to express thoughts and feelings. So this is cool about your parietal lobe. So we have two areas on the front of our frontal lobe here. And one's called Brock's area, and it's on the right half, and I forget what the heck the other one is called, but basically this one on your right half controls talking. This one on your left half controls singing. Remember, both halves mirror each other, and this is replete throughout your brain. You have different centers that are kind of in control of certain things, and this is one of them. There was a guy that got into a car accident, and where his Brock's area was damaged in the car accident. Nothing else. He recovered fine, but he couldn't talk. He could understand everybody fine. He could understand what you were saying. He could write down his thoughts, no problem, but he could not form words. It was impossible because his Brock's area was destroyed in the accident. So they rehabilitated him by using the mirror side of his brain with the singing area. He could still sing. I don't know how well, but he could still sing. And so crazy, we retrained his brain to make him talk again by making him sing everything he said. And he literally did. He was like, I need to go to the bathroom. But eventually, over time, he cut out the sing-songy bit, and now he talks fine. Because we retrained the brain, and that's called elasticity, which is really cool about your brain. Your brain has opposite but kind of similar areas on both sides, and sometimes we can retrain the brain to do everything. And this is like for those of you going into things like, sports medicine and physical therapy. This is basically kind of one of the premises behind physical therapy, is that we can retrain the nervous system to use different neurons to form a new route to reuse those parts of the body that we thought we lost. So that's because of our brain's plasticity and elasticity. So it's actually really, really, really good at rearranging itself and rewiring itself. And again, this is why the neurons don't touch each other, so we can rewire ourselves. It's not easy to do, but you can do it. which is really cool for something that, if we lose sections of our brain, that our brain can actually relearn and recompensate for that, even though we've lost sections and we're never going to get that back because we can't regenerate neurons. Isn't that crazy? So, yeah. Occipital lobes. So again, this is at the back. This is for basically combining visual images with other sensory experiences. So basically, it's responsible for vision. Why is it at the back of your skull and not the front next to your eyeballs? I don't know. Nobody asked me. It's, again, the same thing with the other back. Why does your left brain control your right side and your right brain control your left side? I don't know. Nobody asked me. This is weird. Like I said, weird brain things, which is going to bring me to my next weird brain story. Anyway, insula of R'lyeh, or island of R'lyeh. Basically, this functions in humans ranging from sensory and affective processing to high-level cognition. When you're sitting there going, "What is cheese?" and you're having a deep thought and spacing out the window. Like me in math class. Anyway. Oh, why am I'm not in slideshow anymore. When did I do that? Oh yeah, when we were looking at dear Phineas Gage. Alright, so now, the split. Now this is where we get into weird brain stories, part 2. Or part 4 at this point. I don't know. I have so many weird brain stories, it's not even funny. So, if you know this, the movie Doctor Strangelove, please watch it sometime. It's funny. It's supposed to be funny. It's satire. It's black and white on purpose. It wasn't filmed in the black and white era, but it's black and white on purpose. It's kind of funny. So anyway, the cerebrum is split into 2 halves. We already talked about that. They mirror each other. We already talked about that. There is a divide called the longitudinal fissure, and the 2 halves are connected by one thing and one thing only, and it's called the corpus callosum. The corpus callosum is the only thing that keeps these 2 brain halves working together. Now, the crazy part is you can cut it and you wouldn't notice a difference at all. And we have cut it on several people, especially to get rid of insane seizures. There used to be a mal-type seizure that was like really, really bad. And back in the 70s, I want to say, and the only way to get rid of it at the time, now we've got drugs that actually target it, and we don't have to do that surgery anymore, but we'd cut the corpus callosum. And before this actually factors into some research we did on brains, but before that, I think in the 1900s, there was a woman who had a stroke, and she recovered beautifully. And one night, she woke up to somebody choking her to death. So she woke up and she started struggling, fighting this assailant, doing everything she could. Her husband rolls over, because he wakes up. He's like, "Oh my God, honey, are you okay? Are you okay?" And she's like, "Ah," and he comes over and he looks, and it's her own left hand that is attacking her. True story. So she goes to the doctor the next day and she goes, "Doctor," this is the one that helped her survive and recover from the stroke. Remember, this is 1900s. She goes, "Doctor, my left hand almost killed me last night." And instead of going, "Go away, crazy lady. I have no time for your nonsense," he actually turned around and said, "Tell me more." And she went, "So this is what happened. My husband actually had to pull my left hand off of me." And he goes, "Really? You need to tell me if more of this happens in the future." So she kept a log, and he kept a log. And he actually believed her. He didn't, say, "Oh, she's a crazy lady, go away." He actually was terribly interested in all of this, and he wrote it down. And he noticed, he goes, "I bet you anything that the stroke you had something to do with this." And she was just like, "Oh gosh, and I guess there's no way to fix it because I had the stroke." And he goes, "Yeah, there's no way to fix it." And they're just like, So they kept an eye on it, and it didn't happen again for the rest of her life. She finally passed away, and she actually, in conjunction with her doctor, allowed him, after she died, to operate on her brain and look at what possibly the stroke damaged. And he went in, pulled out her brain, looked at it, and the corpus callosum was destroyed from the stroke. And he was like, "Huh." So he wrote a paper, and then that was that. And it wasn't, like I said, until the 70s we had those people with those grand mal seizures, or the certain type of seizure. It was a certain type of rare seizure, and there was only a handful that went through it. But we had to cut their corpus callosum, and then we started noticing they too, whatever their non-dominant hand was starting to do weird things. And we call that alien hand syndrome, or Dr. Strangelove syndrome, because Dr. Strangelove had it too, for comical effect in the movie. But yeah, his hand kept attacking him constantly in the movie, and it kept doing. It's like his hand was a Nazi, and the other half of him was faking it. It was funny. Check it out. Anyway, funny movie. If you haven't already seen it, highly recommend. Very funny movie. Anyway, so basically, and it's where a person's limbs start doing whatever. And this actually led to Nobel Prize winning research. So, fun thing, what happened was, these guys, so they were, oh God, what is it? So anyway, they were sitting there, so what they do is they take these people in that had the corpus callosum cut, and they'd start doing some things on them. So the first thing they had them do was they had them cover their left and their right eye. Because remember, left half controls your right half, and right half controls your left half, right? Well, they wanted to see, because the corpus callosum is cut, if there was a difference in recognition with things if they just covered the eye. So what they do is they give them a paddle to cover one of their eyes or their other eye, and they'd hold up an object. And they said, we're going to hold up a different object every time, except they didn't. So the guys would go in and they're like, all right, we want you to cover your right eye. So he'd cover the right eye. They'd hold up an apple, a red apple, and they'd go apple, because the left hand of the brain would be saying it. And when they covered their left eye, and it was the right brain's turn to see it, they couldn't say what it was, but they could say what its shape was and what its color was. He'd sit there and go, red, round, red. And he's like, well, what is it? Red. So the right brain doesn't necessarily see what it is. The left brain knows the name for it, but the right brain kind of sees all the parts of it. Like, it's red, it's roundish, stuff like that. And they did that with several different things, and come to find out, yeah, so the left brain seemed to have the names for things, whereas the right brain seemed to have the concepts for things. Then they did another test, and this is the cool test. What they do is they give them a pouch filled with like little tiny handheld toys and stuff like that. So they'd put in like an egg, a fake egg, and like, you know, a rubber ball, and of a different color. And they'd put it in with all these other little handheld toys as well, and shake up the bag. And so basically what they'd do is they'd show two things, but they wouldn't mention the other thing. They'd show a red ball or something like that. And they say, I want you to dig in this pouch and pull out the red ball. Okay? But the entire time they were saying this, they had like an egg in the other hand. They didn't mention the egg. They didn't wave it around. They just had it in their hand. So they're like, I want you to find this red ball. Okay? And the guy's like, okay. And then they dumped both things into the bag with a whole bunch of other little toys similar to it. And they'd shake it up and they'd hand it, and they'd time how fast they'd pull it out. The timing was not part of it. It was actually kind of a cover. So what happened is the person with alien hand syndrome would literally dive in, and they'd start looking with both hands, crazily enough, and they'd pull out the red ball in their dominant hand going, I got it. And they're like, what's in your left hand or your non-dominant hand? And they'd pull out the egg. So goes to show that, yeah, both sides of your brain are actually seeing and processing things completely differently from each other. And the only thing that's really keeping them together and working them at the same time is the corpus callosum. But if it gets cut, you can still live just fine, but your non-dominant hand might start doing things on its own. So, talk about split personalities. Isn't that crazy? And like I said, we did a lot of, research on this and got Nobel Prizes for this research on these people that had their corpus callosums cut. It's really interesting stuff. Anyway, basal nuclei. Also known as basal ganglia, these are masses of gray matter deep within your cerebral hemispheres. These are relay stations for motor impulses originating in the cerebral cortex and passing into the brainstem and spinal cord. They facilitate and help control your voluntary movements. Your limbic system. So, part of our cerebral cortex in the medial parts of the frontal and temporal lobes. So, frontal, that connect with the hypothalamus, thalamus, basal nuclei, and other deep nuclei. And this controls emotional experience and expressions and can modify the way a person acts. So this is when you're getting a frontal lobotomy or a pike shoved through your, exploded through your face. This is what it hits. So produces feelings as fear, anger, pleasure, and sorrow. Also reacts to potentially life-threatening upsets in a person's physiological or physical condition. So the limbic system. Also, limbic system is where you kind of figure out smells. So this is why smell is associated with memory. Is because your limbic system is all fun communicated. The limbic system, especially when you're looking at psychology, that's your friend looking at the limbic system. And remember when I was talking at the beginning of chapter 10, when I was telling the story about, the students, at-risk students who are always constantly with fight or flight on, this is what it screws up, is the limbic system. The limbic system, when it's put under stress constantly 24/7 and is never given an out, this is the system that is punished the most. Like I said, fight or flight is only supposed to be in events that, put us in danger or something like that, puts us under enough stress that we think we're in danger. So therefore, we respond properly and hopefully live through the ordeal. Well, the limbic system is not designed to be forced into fight or flight 24/7. And like I said, this really screws things up. And that's why you get the emotional experience, expressions, modifies how people act, producing feelings like fear, anger, pleasure, and sorrow, blah, blah, blah. So, yeah, that's your friend, the limbic system. So if you feel like you're under a lot of stress, yeah, your limbic system is not responding to that well, and that's why doctors are like, reduce stress. And it's like, well, gee, make me a millionaire then. Because it's like, you know it, I know it, you know what I'm talking about. All right, so let's talk about the spinal cord real quick. Like I said, it's in reverse. Gray matter on the outside of the brain, white matter on the inside of the brain. White matter on the outside of the spinal cord, gray matter on the inside. So it basically extends from the brain to the vertebral canal, terminates at the level between the first and second lumbar vertebra. Remember, two or more neurons involved in synaptic transmission constitute a nerve pathway. A nerve pathway includes a sensory receptor that ends with an effector that includes as few as two neurons. It is known as a reflex. So this is where the doctor boinks your knee and you kick it and you get a reflex. You have a lot of reflexes. So this is also be defined as an autonomic response to a stimulus, like the doctor tapping your knee with the hammer and your knee goes whee. That's just to check your reflexes, which is funny when I hand it to people to do that in the lab. And for some reason, some people just need to wail on other people's knees. You just need to tap it, guys. You don't need to go, ugh! And don't do it with the pointy part of the hammer. Do it with the flat end. The reason I say this is because some people get a little hammer happy. So, basically, a reflex arc is always made of 5 things. You got your receptor, you got your sensory neuron, you got your interneuron, which is basically bringing it up to the brain and back for a decision, the motor neuron, and the effector, which is basically the muscle of the gland. So, in other words, you get a stimulus like this pin sticking in, or you step on Lego. You get the receptor, the sensory neuron goes, stepped on Lego, brings it to the integration center, which then screams up to your brain and goes, we stepped on Lego, and your brain goes, get your foot off of it, and then it goes back down to the motor neuron, and then that brings it down to the effector, which basically moves your foot off of it. And we all know how quick this reflex arc actually is, which is insane to think about, that it has these 5 steps, technically, sometimes more, but this is the basic, components. Are these 5 parts of stimuli, bringing it up to brain to make this, thing, move it. So, going up or coming down, which is where we got the ascending tracks going up and the descending tracks. And yeah, we actually have parts in our spinal column where we've got things going up and things going down. Notice that things going up are all in the white. They're all in the white. Nobody's in the gray. because we need quick thinking. And then, again, you notice a lot of the descending tracks are in the white as well. So again, remember that's that myelinated, so therefore the transmission goes faster than it would in the gray. It's kind of interesting. So ascending tracks going up, descending tracks coming down, telling our muscles to get the foot off the Lego, or, oh god, the cat's claws are in my thigh again. Because when my cats sometimes take up, the loaf position on my thigh, they sometimes put the claws in. So again, let's go back to this. So we just talked about motor neurons. Sensory neurons get their own chapter, which is chapter 12, so we won't talk about them until later. So we just talked about the motor neurons, so now let's talk about somatic nervous system versus autonomic nervous system reactions. So this is where we're starting to break down now. We just got done talking about these. Now we're in peripheral. We just talked about the 5 parts of the motor neurons and whatnot. Let's talk about, and the sensory neurons get chapter 12 all to themselves, so let's talk about these guys. So again, peripheral nervous system consists of nerves that branch from the central nervous system connecting to the rest of the body parts. This includes our cranial nerves that arise from the brain, and trust me, we are going to talk about them in the next chapter. They get their own chapter. They're fun. And then the spinal nerves that arise from the spinal cord. That's kind of what we're going to be talking about right here. So the PNS can further be divided into the somatic nervous system and the autonomic nervous system. So the somatic connects our central nervous system to the skin and the muscles and conscious actions like dancing terribly. And the autonomic nervous system connects our central nervous system, such as viscera, like our heart, stomach, intestines, and various glands. So we have subconscious actions like digestion. So we don't have to sit there and think about eating dinner. I mean, we do think about eating dinner when we get hungry, and what we'd like to eat for dinner. But I mean, the actual act of digesting. You don't have to sit there and go, "Oh, I'm digesting. Give that to me." Thank God we don't have to think about these things. Like, I'd probably be dead by now if I had to think about breathing. I don't know about you. I know what. What about you, Monty? Yeah, you'd definitely be dead. Anyway. Without me, he definitely would be. I have pictures where the snake missed the mouse completely. And there's a reason why he eats dead mice. Because he can't. He actually has scars on his body where he fought a mouse and lost. Yes, you're looking at a snake who lost to a mouse. Actually, it happens quite often. Anyway, so nerves are essentially bundles of axons, but they have specific levels of organization. So we got your endoneurium, which is basically a small amount of loose connective tissue that surrounds individual axons. Peritoneurium, which is the axons organized into bundles called fascicles, and each fascicle is covered in a sleeve of loose connective tissue called the peritoneurium. Or perineurium, excuse me, there's no T in there. And the epineurium, this is dense connective tissue that covers large bundles of fascicles, which constitutes a nerve, which is, if you've ever hit a nerve, you know exactly what I'm talking about. So, I am talking about the cranial nerves in this chapter. Sorry, I thought it was in the next chapter for some reason. So anyway, classification, there are basically 20. No, wait, yep, 12. 12. I can read Roman numerals. There's 12. That's what I thought. Sorry. Anyway. I hate this. Why did I want this one first? Anyway, classification about cranial nerves. There's a couple different ways you can classify these 12. The first way is you can do it by like sensory motor mixed, which is basically mixed or both motor and sensory. So if you want the sensory only, you got the olfactory nerve and the optic nerve and the vestibulocochlear nerve, which is basically hearing. Optic, of course, is eyes, and olfactory is smelling. Then you got your motor cranial nerves. So these only contain efferent motors. So your ocular motor nerve for moving your eyeballs around, your trochlear nerve for, trochlearing, which is talking, your abducent nerve, your accessory nerve, and your hypoglossal nerve. We'll actually go over more of what these guys do in a minute. And then you got your mixed nerve. So these are both sensory and motor. So you got your trigeminal nerve, your facial nerve, so you can move your face around, a glossopharyngeal nerve, so you can, swallow and stuff, and the vagus nerve. What the? I don't know anybody from there. Anyway, so I can leave a message. So let's talk about the 12 pairs of cranial nerves. Now, I actually have a video. This guy is really good, so you can remember them. Because, yeah, I'm going to talk about some of these in the test, but honest to God, memorizing them all would be painful. So this guy actually worked out a kind of a mnemonic. It's a really good video. I linked it in my courses. Highly recommend watching if you want to get these guys down pat. It's a great way to remember these guys. So number 1, the olfactory. These are sensory. Fiber conduct impulses with sense of smell, obviously. If damaged, the sense of smell is affected. We'll talk more about that in the next chapter. Optic, again, these conduct basically associated with vision. Ocular motor, this is basically to raise the eyelids so you can flirt. And adjust to light focus lenses, which is something we don't really think about. I mean, our eyes kind of do it for us, so we don't really have to think about that one. So if damaged eyelids and the ability to focus an eye is affected. Trochlear, so this is again movement to the eyes. This is so we can move it around. Trigmeal, this is a mixed one. It's a sensory and motor of basically the surface of our eyes, which is if you've ever seen in movies, you know, somebody going at an eyeball with a needle and you start freaking out like my husband. Yeah, that's your trigmeal nerve going, oh God, and like associating with what you're seeing in the horror movie. And it's weird because he loves horror movies, but he can't stand it when they mess with eyeballs. And I'm just like, I'm not the biggest horror connoisseur, so I don't know. Anyway, upper jaw, lower teeth, mastication, chewing. If damaged facial movement and senses are affected, abductions. Your abductions is basically, again, eyes. Notice there's a lot of things working on your eyes. Then you got your facial, which is basically a mixed nerve. So taste receptors, motor for facial expressions. Tear glands, salivary glands. It damages taste, you know, abilities to show expressions are affected, like, you know, Phineas Gage would. Vesticochlear, so again, equilibrium and sense of hearing. If damaged, this could mess with equilibrium pretty badly. Glossopharyngeal, so again, pharynx, tonsils, tongue, carotid arteries, motor, glands used in swallowing. Vagus, these are mixed nerves. This is pharynx, larynx, esophagus, thorax, abdomen, motor fibers. Basically, if you damage this, it can screw up speech, a lot of swallowing. Accessories, so this guy conducts impulses toward a soft palate. So if you've ever gotten food stuck in your soft palate and you're going, trying to get it out, yeah, I know that one. Larynx, pharynx, neck and back. Damage affects movements of neck and back. And your hypoglossal, which is basically the move to tongue. You know, so you can do this. Which, interestingly, is genetically related. So, yeah, come to find out, if you do this, if you can't do it, blame your genetics, because that's entirely genetic. Which is fun, because there are people who can roll their tongues and there's people that can't roll their tongues. Like I was really interested in my son when he was born, other than because he was my son. But my husband can't roll his tongue. He's a non-tongue roller. He can't do this. He just can't whatsoever. And I wanted to see who Wesley got that from. See if Wesley got non-tongue rolly or tongue rolly. He got tongue rolly. He could do it too. As soon as he was old enough, I was like, do this. And Wesley was like, and I'm like, yes. My genetics have gone to my son. And, you know, I'm sorry. The biologist in me was amused. Highly recommend, again, this guy right here. He goes over great pneumatic ways to remember each one of the 12 nerves if you're worried about that. If you're not, I'm not going to beat you with them, but who knows what somebody's going to do to you in the future. So, like I said, really useful video for remembering all 12. So anyway, there's 31 pairs of spinal nerves that originate from the spinal cord. And actually, if you can get all of them out, you're really good at that. But anyway, so the anterior root of each spinal nerve consists on axons around the motor neurons whose cell bodies lie within the gray matter of the... So these guys go into the gray matter. If you're wondering, wait, if the ascending and descending is all in the white, which makes sense because it's a fast track, what's going on with the gray? Well, that's where these pairs of spinal cord nerves come from. So anyway, they lie in the gray matter, the posterior root, has a posterior root ganglion. And this contains cell bodies whose axons are conducting impulses inward from the peripheral body parts. So like you're touching something and like you're feeling something and you're going, oh. And then the rami bundles, which are right here, are connecting to sympathetic ganglion to spinal nerves, such as gray rami, which is unmyelinated, or white rami, which are myelinated. So remember, again, if it's got the swan cells all over it, and this is where the swan cells are, by the way, so these guys have the white ramus, has all the swan cells on it, and the gray ramus do not have the swan cells on their axons. So, anyway, so the anterior branches form complex networks called plexuses, instead of continuing directly through the peripheral body parts, except for T2 to T12. So if the cervical plexuses, that's C1 through C4, they supply to the muscles in the skin of the neck. So that way I can feel Monty moving around my neck right now. The brachial plexuses, which is from a C5 to C8, they supply the muscles and shoulders in between the neck and the armpits, which unfortunately my shoulders is where I like to store most of my stress, which is why they seize and then I can't move anything. The lumbar plexuses, they supply the lower muscles in the abdominal wall, which I wish I had less fat and more definition, but hey, that's because I'm lazy. Anyway, sacral plexus is from S1 to S5, and they supply muscles in the genitalia, buttocks, thighs, legs, and feet. Longest nerve in your human body, test question, the sciatic nerves. Again, he goes through all that. And again, now we've got done with him, let's talk about autonomic, and then sympathetic and parasympathetic, and then we'll be done. So, autonomic nervous system, this controls subconscious actions by functioning independently and continuously without effort. So, in other words, while the somatic nervous system is the part of the peripheral nervous system that controls voluntary control of the body, where the autonomic controls the involuntary actions of the body, parts of the brain that controls the ANS are the cerebral cortex, the hypothalamus, the amygdala, and the brainstem. Again, he's going to get more and more important as we go along, especially next semester when you take 169, or whenever you take 169. So, hypothalamus, he's a big boy, a part of the autonomic nervous system. So you got your sympathetic, this is always operating without us noticing, but is most active during energy expending stressful emergency situations. So that's why it's called fight or flight response. Regulates bodily functions such as heart rate, digestion, respiratory rate, pupillary response, urination, and sexual arousal. So yeah, it kicks on during the Netflix and chill moment too. Anyway, parasympathetic division is most active during ordinary restful conditions like rest and digest, and counters the effects of the sympathetic division to return the body to a state of rest following stress. Because like I said, we should not be in stress 24/7, although the universe seems to beg to differ on occasions. Rude. So again, you'll notice how these guys basically control. So you got the cranial nerves and the parasympathetic. So this basically sits there and constricts the pupils, stimulates saliva, keep the air moist in your breathing, constricts your airways, slows the heartbeat. This is all rest, by the way. Notice your saliva digest basically doesn't release any glucose, instead starts storing it up just in case. And again, stimulate activity in the intestines, so you're digesting. So again, this is rest and digest. However, if you get into dangers, that's when your thoracic and lumbar nerves, the top two of them, basically turn on, your sympathetic. So you dilate your pupils to get more light in so you can see, around you better. It inhibits making saliva because, again, you're not really thinking about being hungry when a dinosaur is chasing you. Or zombies, whatever. Pick your favorite. Anyway, so it relaxes the airways so you can get good deep breaths for running away. Increases your heart rate so we're pumping the blood everywhere faster so you can get oxygen around faster and can, with this, again, it shuts down the digestive system. So the digestive system sits there and goes, we need to stop because everybody's freaking out. And the liver increases and starts kicking out glucose because he's your glucose storage. So whatever glucose you built up, he's kicking it out for you. So that way you've got energy without having to rely on digestion. And again, the intestines kind of shut down a bit, go, oh, we've got to make sure we survive. And then the kidneys and relaxes the bladder, which unfortunately means you might, go to the bathroom on yourself in fear. But this also puts out adrenaline, which is epinephrine. And norepinephrine, which is a painkiller, natural painkiller. And then again, it promotes actual ejaculation and vaginal contractions. So yeah, you're turning on your sympathetic system when, again, Netflix and chill. So, now, the ANS has a distinct pathway pattern, as the SNS and the motor pathway include a single neuron linking the CNS and a skeletal muscle. However, the ANS has pathways that includes 2 neurons. Again, we got to back up here. So you got the preganglionic fiber right here. Notice he is myelinated. It leaves the CNS and the synapses with more than 1 neurons, whose cell bodies are with the automatic ganglion. Right here. And then the postganglionic fiber is not myelinated and is basically the axon of the second neuron and extends into a visceral effector. In other words, telling your stomach or whatnot to turn off, turn on, depending on what's going on. So we have a 2-step thing going on here to tell the body whether to be in rest or digest or fight or flight. That's basically what I'm getting at here. And I still have hiccups. So anyway, in the sympathetic division, where the preganglionic fibers go through white rami, they can merge into 2 other types of ganglia. So you get your paravertebral ganglia or your collateral ganglia. These are anterior to your vertebral column, and they're close to the large abdominal arteries. Or your sympathetic trunks ganglia, which are also found along the sides of your vertebral column. Now, these fibers end in special hormone-secreting cells, and each one of these release one of these hormones. And one of them is epinephrine, which we know as adrenaline. And we're going to talk more about these in the beginning at the next semester. So if you take 169, we pretty much jump right into this. So anyway, you got norepinephrine, and which is actually to pain receivers, and acetylcholine. So anyway, so epinephrine's the most common of the 3 of these. Again, we're going to talk about these fun boys later, so they get to come up again pretty much right if you jump into 169. So, after the sympathetic diversion jumpstarts your system, the parasympathetic throws you back in reverse. So it brings the body back to a state of equilibrium, again, homeostasis, because we are not built to be stressed all the time. So as the heart rate decreases the release of hormones into the bloodstream, and the activity of the parasympathetic causes more localized reactions than the sympathetic does, as much of its output is to specific organs. It's pushing out a lot of things to the heart. It's pushing out a lot of things to go, liver, release your glucose. And it's pushing out a lot of things to, your lungs to relax, get those deep breaths in, so that way the heart rate can go up, and then we can push that oxygen around the muscles so we can run away from the zombies or the dinosaurs or whatever. Or the scary clowns. Whatever. So, nerve plexuses, these form in body cavities where parasympathetic and sympathetic nerves intermingle, and dual innervation, which is organs receive instructions from both divisions, like your digestive system. It gets signals from both. It's like, yeah, turn on, we're in rest and digest now. Turn off, we're in stress time. So dual innervation is basically when certain systems are just like, oh. Again, he goes over it with animations. And again, with animations. And again, with animations. Yeah, we just went over a ton. So definitely feel free to watch these videos if I lost you along the way. Again, with animations, it makes all the difference, I find, in it. And I wish I had animations, but I don't, because I am just an instructor. I don't have that kind of a budget, nor the talent. But with that said, there you go. We have just covered all of Chapter 11 in a nutshell, with crazy stories intertwined. And with that said, we only have one more chapter left. Yeah, all we have left is Chapter 12, where we talk about the special senses. Pretty crazy, huh? We're almost there, guys. You did it. You're pretty much at the end. So with that said, I'll see you in the next chapter. Bye!